there's one differential equation that is extremely important, and it happens all the time, is that the derivative is equal to y. Now what this means is that the slope of your function, the way it's changing, depends on how much is there already. So, for example, let's say that you were just talking about bacteria. At time equals 0, you have one bacteria, and that one bacteria can gain one more bacteria. Now, the reason that that depends on y, like this is saying, is every one bacteria will contribute to more bacteria. Now, if you include more bacteria, then you're going to grow faster because you already have more bacteria. So the rate of growth depends on how much is there already. So you can kind of imagine that you start low, and then you start growing, and that's population growth. So let's actually go into the calculus involved here. This would be dy dx is equal to y. And again, that's saying that the rate of change, the rate of growth, the rate is equal to how much is there already. So we're going to multiply by dx and divide by y. And so we're going to have 1 over y dy equals dx. Now it's separated, so let's do an integral on both sides. The integral of 1 over y is ln of y. The integral of 1 is x. And don't forget the constant. Alright, and kind of like in that complicated example we ended with last time, you can e to the, on both sides, e to the that and e to the that. And then e to the ln of something cancels out, so you just have y equals e to the x plus c. Now, I'm going to rewrite this as e to the c times e to the x. And if you think about it, all I'm doing is, instead of adding exponents, I'm multiplying bases. In algebra, normally you would take this and combine them. I'm separating them. And we talked about last time that when you have a constant and you do something to a constant, it's still just going to be a number, still a constant. So most people will write this now as y equals c e to the x, because e to the c turns into just a number. That's our constant. Now, this explains where our population growth model that you learn in pre-calc and algebra, where it comes from. Often you're going to see this kind of like PERT, where you have a principal, e to the rate times x, and that's where it comes from. Now, we could do this all over again and put a little r here, and that would represent that r right there, and that's how it would sneak in. But the point of this is that this is your initial condition, meaning that that's the starting amount for your population. And if you were to use this right here, there would be a growth rate with r. So just be aware that when you were doing this, this is a separable differential equation. These population growth models are based on the fact that the rate of change depends on how much is there.